and welcome to yet another video on data analysis concepts. I am Professor Mangesh Joshi, working at Sri Ramdev Baba College of Engineering and Management, Nagpur. So in today's video, we will be covering contents that is descriptive statistics. In descriptive statistics, we will cover measures of central tendency, that is mean, mode, median, and measures of variability, that is standard deviation, variance, range, quartiles, and interquartile range. Now in this video, we will cover the data exploration stage. Okay. So descriptive statistics are brief descriptive coefficients that summarize a given dataset, which can be either a representation of the entire or a sample of a population, right? With descriptive statistics, you are simply describing what is or what the data shows. Basically, you are describing the data. Okay. So these descriptive statistics are divided into two parts. One covers the measures of central tendency, that is mean, median, mode, and other part covers measure of the spread or measure of the variability. So in measures of variability, we have standard deviation, variance, range, quartiles, and inter-quartile range, that is IQR. So let us see the measures of central tendency, how to calculate mean, median, and mode in a series of data values. Now suppose, imagine a case where you have 9 students from 1 to 9 roll numbers, and they have scored some marks. Roll number 1 scored 13 marks, 18, and so on. So you have total 9 students with their marks. If you want to calculate the average or mean of the marks, it is very easy, that you have to add all the elements or all the values from 13 to 13, and then you have to divide that summation by number of elements in that set, right? So you have got the average, that is mean value of 15. Now median is the middle value of an ordered data. Remember, it is given that the data should be ordered. So for example, if you want to find out the median of this set, so first of all you have to arrange, okay, in ascending order or descending order. So we have identified the median as 14 because it is the middle value. You have 4 values on the left hand side and 4 values on the higher side. Okay. Now next is the mode. The mode is the number that is repeated more often. Okay. So if you can observe, the number 13 in the complete data set is repeated 4 times. Okay. So that's why the mode of this data set is 13. So these are the measures of central tendency. Now for calculating mean, mode, median in Python, you will require only one library from this, that is import numpy as np. So whenever you are using as keyword, okay, it is nothing but it is an alternative name, right? So you can use np word in your program, right? So let us see how to calculate some random numbers. So this is very important function when you are calculating descriptive statistics. Okay, so the function is rand_int, that is it will generate random integers. Okay, all the values generated will be integers. Now what is this? So this 1 represents the starting point Okay, this second represents the ending point, means you will get all random numbers of integer data type between 1 to 10. Okay, and the third parameter is how many values you require. That means you require 100 values between 1 to 10, right? Ultimately you are printing it, so you are getting a list. So these are the 100 numbers which you have generated randomly. Now second function is rand_n. It is normally distributed random numbers. It is normally distributed random numbers. Means all the values will follow the normal distribution. Okay. So it takes only one parameter, that is how many numbers you want. So if you type 10 over here, you will get 10 random numbers which are normally distributed. Okay. And the third function is simply random, np.random.random. So it will generate 10 numbers randomly, which may or may not follow the random normal distribution. Okay, so these are important functions which you will require to generate random numbers. Now, how to calculate mean, mode, and median. So for this, I have generated 10 random numbers starting from 1 to 10. Okay, so I have printed those series of values. Okay, so to print mean of the data set, there is a simple function which is called as mean. So inside np module, you have mean function, and you are passing the data set A over here. Means this will print the mean of the data set, right? And the second function, which is a median. So simply by typing np.median, you can access the median function inside module np, which is nothing but numpy, right? So here the mean is 5.9 is displayed and median is 6.5 is displayed, right? Now to calculate mode, you will require another package, that is statistics package. Okay, so we have seen various libraries you will require. So you will require import statistics as stat, because mode function is not available in NumPy. Okay, so you have to import statistics as well. So we have imported statistics as stat. So you can use stat keyword. Now we have again generated random numbers, 10 random numbers. So mode is the most repeating value in a sequence. So you can see that the 1 is repeated for more number of times, that is 1 and 3. So 3 times 1 is repeated. So that's why the mode of this data set is 1. In certain situations, you may face that 2 values are repeated for same number of times. So in that example, there will be 2 modes of the data set. But in this case, the mode is 1 because only 1 is repeating 3 times. This is about mean, mode, and median. The second part of this video is measures of variability. Okay, so we have already seen standard deviation, variance, range, quartiles, and IQR. So first of all, we have to understand what is standard deviation. It is denoted by the sigma sign. So standard deviation is the measure of spread of your data from an average value. Okay, so suppose you have this as average value. So if the spread or the of the data is less. Okay, so the curve will be like this. Okay, you have the mean value over here, right? If the spread is large, so you will have the less heighted curve. You can see the difference between these two curves. This is less spread and this is greater spread or larger spread. Now what is the standard deviation? Okay, so let us see, there are suppose say 50 students in your class. Okay, suppose number of students equals to, suppose let us say 50, and you have recorded their heights. Okay, you have collected the data regarding their heights and you noted down the height of say all the 50 students. Suppose student 1 is having a height of say 5.6. Okay, and similarly you have recorded all the height of all the students. That is, let us say this n number is having height of 5.9. Okay, so you have recorded the heights of all the students. Now you have calculated the mean and the standard deviation. So assume that the mean height is 5.5 feet. Okay, let us say the maximum height of a person in a class is 6.5 feet, and suppose the least height is 4.5 feet. Okay, so you will observe that as per your normal natural phenomena, that you will get more number of students near to this mean line. Okay, that is, let's say there will be say 10 students having height 5.5, or there may be 5 point, or say 8 students having 5.6. Similarly, there will be some of 7 students having height 5.4, like that. Okay, so you will see that at the central value or at the mean value you have more number of students, and as you progress towards right or left side, the number is getting reduced. Okay, so this is basically a normal distribution where heights are normally distributed, right? So suppose you plot or you measure the frequencies of students having height 5.5 or 5.7 or 5.9 and so on. So you will get such kinds of bars if you plot a bar chart or histogram, right? And if you join the midpoints of all these bars, you will get an approximately a bell-shaped curve. Okay, you will get a bell-shaped curve, and it is called as a normal distribution curve, right? Now, area under the curve under plus minus 1 sigma, 2 sigma and 3 sigma. So if you observe the normal distribution curve, this value is of 0 sigma. That is the mean value. Okay, this value represents your mean value. Okay, this is your mean value. Now, if you calculate a standard deviation of this and you take plus minus 1 sigma from the mean, you will observe that in this region you will have 68 point, around approximately 68.28% of the population will lie inside 1 sigma. Okay, if you take 2 sigma plus minus 2 sigma level, you will see that it will cover your around 95% of the population. 95.5% of the population will come under 2 sigma level. And if you take plus minus 3 sigma, okay, so you will notice that your 99.73% population will come under this curve. Okay, so this is area under the curve and corresponding standard deviation level. Now, how to calculate standard deviation and variance in a Python? So we have created a list with a random function, that is random integer. We have generated 10 values. Okay, so simply there is a function that is np dot standard, that is std. In this similar way you have calculated the mean. Okay, so using this function in np module, that is numpy module, you can calculate the standard deviation. And variance is, there is another function that is dot var. You can calculate standard deviation and the variance of a list in this way. Okay, you can see in the output you are getting your random array, integer array of 10 values having standard deviation 2.569 and variance as 6.6. Next measure is range. So range is nothing but the maximum value minus minimum value in the dataset. So if you go back to our this diagram, you can observe that suppose maximum height is 6.5 feet, okay, and minimum height in the class is 4.5 feet. So what will be the range? In this case, the range is equals to maximum value in the dataset minus minimum value in the dataset. So this range will be equal to maximum value is 6.5 feet minus minimum value is 4.5 feet, which is nothing but 2 feet. Okay. So range will be 2 feet in this case, maximum value minus minimum value. So how to calculate maximum value and minimum value? There is no direct function in NP to calculate the range, but you have a function that is max function and mean function. Okay, so you can use np.max of a to calculate the maximum value in the dataset, and you can use minimum of a to calculate minimum value in the dataset. And to calculate range, you have to print like np.max of a minus np.minimum of a. You can see that the dataset is this. Maximum value is 9, minimum value is 2, and range is 7. That is 9 minus 2 is 7. A very important thing is quartiles. So what are quartiles? So quartiles are the values that divide your data into quarters. Okay, they divide your data into 4 segments according to where the numbers fall on the number line. The 4 quarters that divide the dataset into quartiles are, so lowest 25% of the numbers, that will come in quartile 1. The next lowest 25% of the numbers up to the median, it will come in quartile 2. The second highest 25% of the numbers above the median, it will come in quartile 3. And highest 25% of the numbers, it will come in quartile 4. So as quartiles divide numbers according to their position on the number line, you have to arrange the numbers in order, right? So as the median word is there, you have to arrange all the numbers in ascending order. Okay. Now we have already discussed about quartiles. Now there is one more term, that is inter-quartile range. Okay. So inter-quartile range is what? Okay. So there are many measurements of the variability of data set. We have seen the range, we have seen the standard deviation, okay, which tells us how spread out our data is. Okay. But what is the problem in this range and standard deviation? So these two measures of variability are sensitive to outliers. Okay. Suppose you are having normally distributed population and you are having only one student of say 6.5 height. Okay. And you are having only one student of say 3 feet or 3.5 feet. Okay. So in this case, what will happen? Your range will be 6.5 minus 3.5, that is 3. Okay, but that there is only one student. So you may not be able to infer any information from it. Okay, so that is the basic drawback in standard deviation and range. So for that, we use one more measure, that is inter-quartile range, which is calculated as quarter 3 values minus quarter 1. Okay, so inter-quartile range, which tells us how far apart the first and third quartiles are, and it indicates how spread out the middle 50% of our data set. Okay, so for example, we will see one example so that the things will get clear to you. So first of all, we will see how to calculate quartiles. So for example, you have a data set, that is this. Okay, you are having this data set, and your objective is to divide the data set into quartiles. So step 1 is arrange the numbers in the orders. In ascending order, you have to arrange the numbers. Okay. And secondly, you have to mark the median. So since there are even numbers, so you have to find out the average of this. So median of this, median is equals to your 6 plus 6 by 2, that is nothing but your 6. Okay, so median is 6. Okay, you have marked the median, and next thing, you just have to divide this data set into two parts if it is an even number. Okay, so you have obtained 6 values on the left side and 6 values on the right side. Okay, so step 3, median of the left side values is quartile 1. So this is your separator. So median of this data set, that is what will be the median? That is again the median value, that is 3, 4. So average of 3 and 4. Okay, so that is your Q1, that is quartile 1. Okay, what is Q2? Median of the right side values of the separator. So again you will see there are even numbers. So these are the two middle values, and average of this is 8. So quartile 3 is 8, and median is Q2. We have already calculated the median, that is 6. Okay, so in this way you can calculate Q1, Q2 and Q3. Now what is inter-quartile range? It is nothing but your Q3 minus Q1, that is 8 minus 3.5, which is 5.5. Right? In this way we can calculate quartiles as well as inter-quartile range. Now, how to calculate this in Python? We have to import numpy as np to calculate. Okay, so you have a data set. So there is one function, that is percentile function, in numpy module. So to calculate quarter 1, so you have to use np.percentile. The first parameter represents your data set, so that is A. The second parameter represents what percentile you want: 25th, 50th, 75th, and 100. Okay, so this is the second, that is 25th percentile, which is my quartile 1. Okay, and similarly 50 is 75. You will get Q1, Q2, and Q3. Okay, so your Q1 is 3.75, your Q2 is 6, your Q3 is 8, and inter-quartile range is 4.5. Okay, this should be 3.5, right? By mistake it is written as 3.75, but it is 3.5. Let us see by manually also. There are how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So middle values are the 6 and 6, which is a median. So median is quartile 2, which is 6. This value is correct. Okay, now you have this data set, that is 3, 2, 3, 3, 4, 5, 6. Okay, and then you have to find out the median of left side data set, so that is mid 3 and 4. So average of 3 and 4 will be 3.5, so it is nothing but Q1. Okay, similarly this is the right hand side, and these are the middle values. Okay, so 8 and 8, the average is 8. Okay, and IQR is 8 minus 3.5 is 4.5. So in this way we can calculate quartiles in Python. So thank you for watching the video. For more videos on data analysis using Python, please do subscribe the channel Untwisted Learning. Thank you. Have a nice day.